Okay, guys, here we go. We're going to be looking at 4-5 day 1. I know it's a little bit reverse of what we've been doing, but as we get going here, I will be able to graph tangent, cotangent, secant, and cosecant functions, list the properties of tangent, cotangent, secant, and cosecant functions, graph the transformations of tangent, cotangent, secant, and cosecant, and use tangent, cotangent, secant, and cosecant models to solve problems. Now, here's the thing. We've done this, and cosecant, secant, and cosecant, and secant, and we are finishing up and doing tangent and cotangent today. Okay, so now, keep in mind, our period for tangent is from negative pi over 2, to pi over 2. Okay, and we're going to get this board all fixed up here for you. So it's from negative pi over 2 to pi over 2. And that's also the tangent's principal value range as well when we do the arc tangent. But notice that here I've got cosine as 0, and here I've got cosine as 0, sine is 0 here, and we bring it on up. We still have 5 key points, okay? We're going to be breaking it up in negative pi over 2 here, and we have a period of pi over 4s. So I got negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. Now, keeping that in mind as we're going through this, okay, those are our key points. And the biggest ones I'm concerned about each time is where it's crossing the graph, my pi over 4 point, and my pi over 4 point. You'll see me when we graph it, I will look for those 3, and I know where the asymptotes are, and then we'll graph it accordingly. Keep in mind, tangent, along with this, as you look at this, is constantly increasing as well. But let's talk about the values of tangent we've got going. And when we look at these, we're looking at the fact that we got negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6, 0, pi over 6, pi over 4, pi over 3, and pi over 2. But one of the things that's really important about this that I want you guys to keep in mind is these values and these values here that I just exposed, they're the same. Okay, they have the same value, and that's why we're so concerned with tangent just being pi, because it repeats itself. Okay, in that 2 pi section, it's the exact same number, so that's why it's considered the same. Okay, so as we go through from the table of values, we can see that tangent and tangent x plus pi are equal. This means the period of y equals tangent x is only pi. The graph is undefined for all odd n pi over 2's. Okay. The principal branch of y equals tangent x is shown above. So this is our principal branch, and everything else makes an adjustment from this. Okay. Now, when we're doing this, again, when we're getting this done, if I'm talking about tangent, okay, and I'm getting this going, we've got negative pi over 2, okay, coming through. I've got negative pi over 2. I got pi over 2. Okay, and I got pi over 4, I got 0, and I got pi over 4. Well, I'm going to be doing the same thing here as I break this down and make my points as I go here. Okay, so I got negative pi over 4, 0, pi over 4. As we're going through here, I got 3 pi over 4, pi, 5 pi over 4, 3 pi over 2. Okay, as I go through, I got 2 pi going here as I get there. And now that I've got that going on, keep in mind, at pi over 4, I've got negative 1, Okay, if I pop that in there, okay. Pi over 4, I'm at -1. Pi over 4, it's 1. So I'm going to be coming up here, going through there. Okay, pi over 4, coming about 1. 5 pi over 4, sitting at 1. Okay, and coming through, excuse me, and coming through here and stopping there. And remember, that's my 0 coming across here. And I'm looking at, again, keep in mind, it's pi over 2 less than or equal to x, which is less than or equal to pi over 2. Okay, so that's my pi, period, as we go through. So now looking at this, you want to take some time. Keep in mind that tangent's an odd function. Reason it's an odd function. It's an even function with cosine. It's an odd function with sine. So when I have that even and odd combo, it's odd. Okay, and so cotangent's also odd as well. So the period is pi, 0, where sine x is 0. Okay, and it's in every time in multiple pi's, where n is a member of the z set, which is integers. Vertical asymptote, where cosine x equals 0 for pi over 2, and all pi over 2. So I got pi over 2, negative pi over 2, negative 3 pi over 2, and so on, and going back up the other way. There's no HA. The domain, okay, x can't be, the pi over 2's, where we have a vertical asymptote. And the range, negative infinity to infinity. Continuity, continuous on its domain. Symmetry, again, is odd. Local extrema, there's none. Increasing, decreasing, increasing on each interval on its domain. Bounded, it's not bounded above or below. And it's end behavior. Now let's talk about end behavior. Limit of tangent x as x approaches infinity, and limit of tangent x as x approaches negative infinity does not exist. The function values continually oscillate between negative infinity and infinity, and approach no limit. So now let's look at cotangent. And cotangent, boy, when we're talking about cotangent, we make a little shift, because cotangent is from 0, x, to pi. Now, this is different from what we've been doing the last 5 days, because sine and cosine are 0 to 2 pi, and secant and cosecant are 0 to 2 pi. Cotangent and tangent are different period lengths. They're both pi instead of 2 pi, but they start at different spots because of the zeros of sine and cosine, because of our asymptotes. So keep in mind, since at 0, we're looking at sine being 0, and at 0, we're looking at sine being 0 right here at 0, if I talk about this here. And every time sine is 0, we're going to have a 0 for our cotangent, or not a 0 for a cotangent, but a asymptote for a cotangent. So here, I got one at 0, but let's talk about our key values, because we're still going to split this up into 5 equal spots. So I've got 0, and I got pi over 4, I got pi over 2, I got 3 pi over 4, and I'll have pi. Okay, so we've got 0, and we're going to break this up, and I've got pi over 4, pi over 2, 3 pi over 4, pi. As I'm going through here, I've got 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and 2 pi. Okay, now as we're going through here, I've got asymptotes sitting at 0, pi, and 2 pi, because those spots are where sine is 0. Okay, and if I go backwards here, I got negative pi over 4, negative pi over 2, and I think I can squeeze in negative 3 pi over 4. Okay, and my zeros, will be at negative pi over 2. So let's talk about those zeros. Negative pi over 2, pi over 2, 3 pi over 2. Now, the difference here is as I'm going down at negative pi over 4, okay, at negative pi over 4, I'm back here in the graph. Well, let's talk about the forward part. That's easier to see. If I at pi over 4, my sine is and cosine are the same, they'll be both 1. Well, that's different because tangent was negative at first. Now this one's positive. Well, this is going to be just the reciprocal, or the flip of what we saw before. And you'll see that I'm just doing 0. The pi over 4 is in 0. Okay, I'll back it up. And I got the zeros and pi over 4s. Okay, so now, as it goes to the asymptote here, that's what our cotangent graph's going to look like. Okay, and they are reflection across the x-axis of each other. So a negative tangent x is the same as a cotangent x as we go through, and vice versa. Okay, so keep that in mind as we're looking at these. And remember, all these points can be found from the unit circle. Now, same stuff. When we're talking about the period, it's pi, 0. Where cosine x is 0, got that listed. Where sine x is 0, got that listed. You know, those are vertical asymptotes. Horizontal asymptote, there isn't any. Domain, its domain is all the way along, except for our vertical asymptotes at n pi's. And our range is negative infinity to infinity. Continuity, continuous on its domain. Symmetry is odd, okay, as predicted. So we'll treat that with like we did with the sine function when we have a negative b. Local extrema, none. Increasing, decreasing on its interval from left to right, keep in mind. Not bounded above or below. And again, the function values continually oscillate between negative infinity and infinity, so it approaches no limit. Okay. Now, let's look at graphing one of these things as we get going here. We're going to talk about a flip here because we got negative tangent, so I'm going to flip it. It's 1, but it's going to flip. Okay, b is 2. And again, I can take, since it's tangent, I got to look at it this way. I got 2x inside and pi and over 2. Now I'm going to divide by 2 here. So that's going to be negative pi over 4. It's the same as multiplying by half. And pi over 4. So I'm looking at this negative pi over 4 and pi over 4. My period has been shrunk, so I have a shrink of my period of 1/2 by a factor of 1/2 here for my b. So I'm looking at this pi becoming pi over 2. So I am going to flip across the x-axis, or reflect. Let's talk about that way. Reflect across the x-axis. Okay, I'm going to have a horizontal compression by a factor of 1/2, okay? And I don't have anything vertical or horizontal. It's just going to be a regular thing on the x-axis, and I'm going to start it at negative pi over 4. So I'm going to break up my axis, okay? And pi over 4s. So I got negative pi over 4, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 6 pi over 4, or 3 pi over 2. We can go back the other way. I got negative pi over 2, negative 3 pi over 4, negative pi, and negative 5 pi over 4, and negative 3 pi over 2. Okay, now I'm going to have my asymptotes at negative pi over 4, pi over 4. Okay, and then I'm going to continue with my 3 pi over 4, 5 pi over 4, and go down here. I'm going to have it negative 3 pi over 4 and 5 pi over 4 for my asymptotes. Okay, now I'm looking at my graph itself. Remember, it's flipped. Okay, but before we get there, let's talk about our critical points, because we got a half, and we got to take our half, multiply it by a fourth, and so we got pi over 8. Okay, so I'm starting at negative pi over 4 for my key values. Negative pi over 4 for my key values. But I go up to negative pi over 8, 0, pi over 8, and positive pi over 4. So these are my key values, or critical points if you want to look at it that way. And I'm going to look at this coming through here, and now we have just negative 1. So I'm going to start with this first range we have here between negative pi over 4 and pi. Generally, when we do tangent, it comes up like this. Okay, I'm still going to have it be 0. It's still going to come across the middle here at 0 on all these. But instead of constantly increasing, because of the flip, it's going to be constantly decreasing. So at pi over 8, if I put it in there, it's going to be 1. And it's going to be like this as I go through. And where I got those is at pi over 4, and I can even put it into the function itself. If you want, you can go pi over 8, excuse me. That would equal that negative tangent of pi over 4. This becomes pi over 4. Generally, at pi over 4, it's negative pi over 4. We're talking about a negative value, but here it's positive 1. Okay, so it's going to go there. And then if I look at the inverse tangent of negative pi over 8, no, that is negative pi over 8. Pi is 2 times pi over 8, which, you know, that's pi over 4, which is generally 1. It's negative 1. So that's where I'm getting my spots, and it's my spot each time as I'm going through my graph. So I just kind of evaluate those. And I've got this going on here at 3 pi over 4. I'm just missing one. This is actually here. So let's fix that. Now, graph itself. Let's use green for my graph. I'm coming through here. And they should all be the same. I'm put my arrows on my graph because it continues. And that's what I've got as I'm coming through here. Okay, so that's our first graph, example 1. And let's look at example 2 here for our cotangent. Now remember, cotangent, we're looking at the idea that A is 3. Remember, it's absolute value. Absolute value of B is 1/2. So I'm going to have a horizontal stretch by a factor of 2 here. And I've got 2 pi divided by a half, because B is a half. So I'm going to have 4 pi. So I've got a graph that's going to take on a vertical stretch by a factor of 3, a horizontal compression by a factor of 1/2. Okay, I've got a vertical shift of 1 unit up. Okay, and I don't have a horizontal shift on that as far as moving it along. So I'll be starting this right at the 0, 0 on my axis. But I just want to make sure you see the fact that we're talking about cotangent. So we're going from 0 to pi, and I got x over 2 here. And while I'm going from 0 to pi, I'm multiplying by 2 here. So I've got x, and that's 2 pi. So we've made our, I've got to fix this. It's not period is 2 pi, this bad habit. It's 2 pi, not 4 pi, but we're still stretching it by that half. Okay, so that's one of the reasons why I do this, to check myself. All right, so now here's the thing. As we break this up, I'm going to break it up in pi over 4s, and we're going to talk about this since it's 2 pi. So my 5 key values are going to be 0, because 2 pi over 4 is pi over 2, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so that's what I'm looking at. And I'm just going to go up by 2s. So I've got my 0, I got pi over 2, I got pi, I got 3 pi over 2, and I've got 2 pi. Okay, and 5 pi over 2, 6 pi over 2 is just 3 pi over 2. Six pi over 2, which is 3 pi. Okay. Now, going backwards, I got negative pi over 2, pi, negative 3 pi over 2, negative 2 pi, and I'll get my last 2 there. Okay. Now, my asymptotes are at 0, and out here at 2 pi, and back here at negative 2 pi. All right, let's talk about where my zeros are. And if I'm really thinking about this as I'm going through here, I'm going to be going across with my axis change. I'm going up 1, my vertical up 1, so y equals 1. Okay, and I'm going to have my zeros. Let's see if we can put reds in there, my zeros. And I'm going to have 0 at pi, 0 at 3 pi, 0 at pi again, negative pi, and 0 at 3 pi. Okay, and now I'm looking at my pi over 4 position, which is my 3 pi over 2. If I put 3 pi over 2 in there, my 3 pi over 2 is like my pi over 4 position because that's 3 pi over 4. I'm going to be looking at the idea that instead of 1, I'm going up 3. So it's 1, 2, 3. And instead of just negative 1, I'm going down negative 3. 1, 2, 3. So over here, 1, 2, 3. Back over here, 1, 2, 3. And I'm over here, 1, 2, 3. And back over here, 1, 2, 3. So I have my graph coming through. And it's coming through here. And it's coming through here. Maybe I made it a little big, but as we're going here, I'll clean those up and put little arrows on. So keep in mind, they're going on forever, ideally. Okay, and then we've got our graph with the vertical shift. So I got a vertical stretch by a factor of 3, and I showed that. And my horizontal compression by a factor of 1/2, and a vertical shift of 1 unit up. Okay, so let's go on to example 3. Example 3, we're checking these out, and we've got just 2 tangent x. So I got a vertical stretch by a factor of 2. Okay, I have nothing in B, and I got a vertical shift up 1 unit. Okay, and keep in mind my A is 2, my B is 1, my period is pi. So I'm going to go, since it's tangent, my period is regularly negative pi over 2 x to pi over 2. So I'm going to get my asymptotes in there. And all my pi over 2's, I've got asymptotes on. Okay, as I step through. And because it's tangent, keep in mind, I've got my vertical up, and because it's tangent, it's going to be constantly increasing because I don't have any reflection here. But I'm going to go up 1 because of my shift, so y equal 1. Okay, and then I got my zeros I'm going to put in. I'll put those in green. At pi, at 2 pi, negative pi is 0, pi, and 2 pi again. And now I'm going to go in from my x's. Excuse me, by pi over 4 position. So here, I should be at 1, but it's 2, so it's up here. Oh, excuse me, down here because it's tangent, and I'm constantly increasing on tangent. And I'm here, so my graph is going to go up like this and pull through there. So each one of these, as I get the group 2 units away and 2 units away, and I'm going to be 2 units away here and 2 units away here and 2 units away here. So each graph, each part of this graph, as I go through, is taken care of, constantly increasing. Okay, get my little arrowheads on there, and we're good. Okay. Keep in mind as well, I didn't show my 5 key points. I kind of did that quickly, didn't I? I've got to make sure that you recognize that it was going to be negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. Those are my 5 keys. Okay. Now, cotangent. This is a negative cotangent. Because of the negative, it's going to look like a tangent. Okay, so I'm looking at A, absolute value of A is 1. I'm going to flip it. Okay, absolute value of B is 1. So my period is still pi. It's pi over B. Okay, so I'm going to have, dividing up by 4, I've got 0, pi over 4, pi over 2, 3 pi over 4, and pi as my 5 key values. Now I'll just call them the 5 keys and make it short here. Now, my axis, I've got an axis that's down here at negative 1, y equal negative 1. Okay, and as I'm looking at this, I'm going to be working with the idea that I've got that axis going on, I've got my asymptote coming in, and those asymptotes will be in at pi because this is a cotangent. Okay. All right, now my zeros, we'll put my zeros in with green, and my zeros are going to happen at the 3 pi over 2, negative 3 pi over 2, pi over 2, negative pi over 2, and 3 pi over 2. And keep in mind, this is normally cotangent, and it's normally decreasing, but we're going to flip it. So now, and I'm going to be going here and here on my axis. Because remember, I flipped what I normally would do, and my A is 1. And we got our graph set up and going. Okay, now we got 2 left here. A for this tangent, absolute value is 1. B for this tangent is 2. Now I've got some funky stuff going on. Since it's tangents, negative pi over 2, less than or equal to 2 times quantity x minus pi over 4. So I'm going to have a shift to pi over 2, but we're going to show you where everything's going to start. I'm going to divide by 2, which is the same as negative pi over 4, less than or equal to x minus pi over 4. Dividing by 2 again is pi over 4 out here. So I have that horizontal shrink by a factor of 1/2. Now I'm going to add pi over 4 to both things. So I've got this adding pi over 4, so I've got 0 less than or equal to x. And I'm adding pi over 4, so pi over 2. So now I'm going to have my 5 keys. 5 keys, remember, I've got to take pi over 2, which my period is. So my period is now pi over 2. So dividing that by 4, the 5 keys go up by pi over 8. So I've started at 0. I've got pi over 8. I got pi over 4. I got pi over 3 pi over 8. And I've got pi over 2. And those are my 5 keys. So now we're going to spread this out a little bit. And I'm just going to pop it in. I'm just going to hit 0. And I'm going to go up by 4s, 1, 2, 3, 4. It's pi over 2. this is pi over 4, and in between I got pi over 8. Okay, so that's the length of what's going on. So I'm going 1, 2, 3, 4, and I'm going to have another pi, and this is pi over 4. This is 3 pi over 4. Okay, and this is 5 pi over 4. And this is 6 pi over 4, which is 3 pi over 2. Okay, and we have the same breakdown going back. So I've got pi over 4, pi over 2, and these are all negative. 3 pi over 4, pi, negative 5 pi over 4, and negative 3 pi over 2. Now, keep in mind, because of this scrunch, it's 0 and pi over 2, I have my asymptotes, but I also have an asymptote every pi over 2 length because I've got a period of pi over 2. So I'm just adding pi over 2's and coming up with my asymptotes. And I've got negative pi and pi over 3. So I got those asymptotes. And I stay on the axis. Okay, so since I'm staying on the axis, my zeros are here. Right? And now it's a tangent constantly increasing. So it's constantly increasing, and I don't have a multiplier in front. So I'm going to be looking at the idea that it's 1 here, 1 there, 1 here, 1 there, negative 1, 1, down negative 1, 1, negative 1, 1, and negative 1, 1. And I can now draw my graph. Now, keep in mind, I had a setup on this graph. As we look this over, I had a horizontal compression by a factor of 1/2. I had a horizontal shift or horizontal translation, move, slide, translation, and I went right pi over 4, excuse me. All right, and that's the extent of our adjustment from a regular y equal tan x. Now, our last one here, we have y equals 2 cotangent 3x minus pi over 2. Now, the 3 is inside, so this makes it kind of tough to do this, but keep in mind, in a cotangent, we're going to go 3x minus pi over 2, and this is supposed to be over pi, and now I solve for x. So I'm going to add pi over 2, both sides, 3x, and this is 3 pi over 2. Now I'm going to multiply by 1/3, so I got pi over 6, x, and 3 pi over 6. Now, as I'm looking this over, I've got a is equal to 2. I've got b is equal to 3. Okay, and my period is pi over 3. Well, if I break the pi over 3 up into 4 equal parts, my pi over 3 times 1/4, that's pi over 12. Okay, so I'm going to break it down in pi over 6's really. So if I move it to negative pi over 6, and that's, excuse me, pi over 6. So I've got pi over 6, and this is pi over 6. Maybe I'll get that as a different color so we can see that. I got pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, and pi. Okay, and it's pi over 6, 2 pi over 6, which is pi over 3. And keep in mind, in between here are pi over 12s. And I'm going to go back here, negative pi over 6, pi over 2, 2 pi over 3, 5 pi over 6, Negative pi over 6. Ooh, I missed pi over 3. I missed pi over 3. We got to redo that. Negative pi over 3, negative pi over 2, negative 2 pi over 3, negative 5 pi over 6, and pi. Okay, so that's our negative. And I'm not changing this any as far as the axis. I've shifted it over, so it's pi over 6s and pi over 2 and 5 pi over 6, and then back here at negative pi over 6 and negative pi over 2 and 5 pi over 6. Those are my asymptotes, and I'm going to get this going on. Remember, it's cotangent. It's on the axis. Okay, so now I'm just going to go to my spots on the axis where I've got to have a 0 here. My zeros are put in, and now keep in mind it's cotangent and it's positive, so it's constantly decreasing, and it's 2. So out here at pi over 12 spot, I'm out at 2, and I'm out at 2, and I'm 2 out, and I'm 2 out, and I'm 2 out, I'm 2 way, and now I just get to fill in. Now, keep in mind, I have a vertical stretch by a factor of 2. I've got a horizontal compression by a factor of 1/3. And I have a horizontal shift, we'll call it a shift, and it's a horizontal shift of pi over 6 to the right. Okay, so those are the things we got going. We got our graph graphed, and we've taken care of it. So that's where we're at. Okay, I hope this goes well. Please visit the summary page that we've got going on. We've got a summary page in back, and check it out, looking at tangent, looking at cotangent, looking at cosecant and secant, and all the trig basic functions, and kind of a list of the highlights of each one of those functions. Thanks, and have a great day, you guys.